Hello everyone, today I'm going to solve this problem. Please pause this video and read it very carefully. In this problem, a projectile is launched with initial speed of 200 meter per second at angle of 60 degree with respect to the horizontal. We have to compute the range R as measured up the inclination as shown in this picture. So this question is easy. First, what I will do, first I will write x and y axis. Then I will write this red color is showing the velocity vector. The initial velocity is 200 meter per second and it is inclined with angle of 60 degree. The purple color shows the inclined surface which has 20 degree inclination. So first we will focus on the projectile motion, the red color vector. This makes our problem easier, and later we will talk about the inclined surface. So we will use our previous concept of projectile motions formula here. So as you know that initial velocity is given, we can find the initial velocity in x direction and in the y direction. So we have to compute the component of v naught. So vx naught is 200 cos 60, and similarly in the y direction the velocity is vy naught is 200 multiplied by sine 60. I hope this is very simple. Till now you can easily calculate. We are not talking about the inclined surface till now. Now what we will do, we will apply the fundamental equations for the projectile motion to calculate the range. I mean x range formula and y range formula. So you can see on the screen I wrote the formula for x, which is very simple and you know it very well. Here TF is time of flight and x naught is the initial range, that is basically 0 in this problem. So in this equation, what is x? Till now we know that horizontal length is x in simple problem. So similarly, I will go back to the picture again and look here. R is what? The distance between A to B. Can we get the horizontal length in x direction? Yes, it is very easy. We know the angle is 20 degree. So we can write x is what? R cos 20. And similarly, y distance will be R sin 20. So we took the components of R here. Now put the values for the x, which is R cos 20 is equal to x naught, which is initial range. X naught is usually 0 and similarly 0 in this problem, plus the velocity, initial velocity in x direction we have just calculated here, that is 100 meter per second, multiplied by the time of flight. This is our equation 1, and in this equation you can see that there are two unknowns, R and time of flight. So we can make a correlation like TF is equal to 0.00940 R. Now we will calculate for the y direction. Y is equal to y naught plus vy naught multiplied by TF half gt square. This is our second and one of the important formula for the projectile motion. So what is y here? We have just calculated in the figure that y distance is r sine 20. And vy naught is 0. Why? Because the projectile starts from the ground. Okay, so there is no height, so we can say y naught is 0. Now the next I am writing the values for vy naught 173.2 multiplied by tf minus half 9.81 tf square. That is very simple, very basic. In this equation 2 you can also see that there is two unknown r and tf. So you can put the value of tf in the equation 2, as you can see by purple line. So now we will calculate by using calculator value for r and for the tf. Based from the information from the equation 1 and equation 2, the value for r is 2970 meter. So here we have used the simple formula. Thank you very much.